Hello dear students, in the previous lecture we have discussed the non-precision measuring instrument, that is the scale and the caliper. Now we are going to discuss the precise measuring instrument. So the very first precise measuring instrument is Vernier caliper. So Vernier caliper is what? Vernier caliper is a device that is used for the precision measurement which cannot be done with the help of meter scale. So first we will discuss the different part of vernier caliper. Vernier caliper are having the different parts, that is first the internal jaw, external jaw, vernier scale, main bar scale and the depth measuring blade. So internal jaw is what? Internal jaw is the jaw or the part of the measuring instrument that is used to take the measurement of the internal parts, that is like hole. If you want to measure the diameter of the hole of a given component, then we can measure with the help of internal jaw. So that's why it is called as internal jaw, because they are used for the measurement of internal dimension. This internal jaw consists of two jaw. One jaw is fixed to the main bar scale, so it is termed as fixed internal jaw, and the other is the movable internal jaw, that is fixed to the vernier scale part of the vernier caliper. So both the jaw together forms internal jaw. Next is external jaw. External jaw is the jaw that is used for the measurement of the dimension from external part. That is, if we want to measure the length of this screw, then we can measure with the help of external jaw, not with the help of internal jaw, externally. So this external jaw is called external jaw because they take the part of measurement from the external of the body. Now it is also made up of two jaws. First is fixed to the main scale bar and second is fixed to the vernier scale part. The jaw which is fixed to the main scale is called as external fixed jaw, and the jaw that is fixed to this movable vernier scale is called as movable external jaw, and together they are called as external jaw. There is a main bar, and main bar is the part which is having the main scale, and the main scale is similar to the scale that we have in a day-to-day life, and the least count of this main scale is 1 mm. This is the depth measuring blade. Depth measuring blade is the blade that is used for measurement of depth. So vernier caliper is an instrument that can give you three dimensions. One is the external dimension, internal dimension, and we can also measure depth. So these are the parts. Next is how to calculate the least count of vernier caliper. So least count is what? Least count is the minimum distance that can be measured by any measuring instrument. So for the vernier caliper, least count is what? Least count is defined as the length of one main scale division, that is the main scale division of the main scale minus length of one vernier scale division, that is the vernier scale division. So MSD is main scale division, VSD is vernier scale division. So according to the principle of vernier caliper, n divisions on vernier scale coincide with n-1 division of main scale. Let us suppose there are 50 divisions on vernier scale division. So how much n is there? N is 50, and main scale division coincides with vernier scale division is 49. According to this, n divisions on vernier scale coincides with n-1 division of main scale. So if there is n is 50, then for main scale value of n-1 is 49. So 1 VSD is equal to n-1 by n main scale division. So according to the formula of least count is equals to 1 MSD minus 1 VSD. By putting the value of 1 VSD, 1 MSD minus n-1 divided by n MSD, So we will get 1 by n MSD. Now, taking an example, if VSD is having 50 divisions, so main scale division is n minus 1 is 49. So what will be the value of least count? Least count is equals to 1 by n. So what is the value of that n in is 50? I have already told you. So 1 by 50 MSD. And what is the value of MSD? That is 1 mm. So value will be 0.02 mm in that case. Otherwise, the standard formula is 1 by n into MSD. How the measurement is taken with the help of vernier caliper. So the general formula for the measurement with the help of vernier caliper is MSR plus VSR into least count, and MSR is main scale reading, VSR is vernier scale reading, and into least count. For example, in this figure, we have to take the MSR, which is either coinciding with the 0 vernier scale or it is before the 0 vernier scale. So we can see that it is 19 here. What is the value of MSR? MSR is 19. And what about VSR? VSR, we have to take the value of vernier scale division, which coincides with the main scale division. So in this figure, this 32 is the value which is coinciding with the main scale division. So VSR here is 32. Least count is according to the vernier caliper, according to the formula which I have told you, 1 by n MSD. So in this way, we will calculate the value of measurement with the help of vernier caliper by putting the value of main scale reading, vernier scale reading, and the least count. So we will get the measurement. So next part is micrometer. Next precision measuring instrument is micrometer. Micrometer is a device that will measure more accurately as compared to the vernier caliper as well as the meter scale, and it works on the principle of screw and nut. So when a screw is turned through a nut through one revolution, it advances by one pitch distance. That is, by doing one revolution of the screw corresponding to the linear motion of a distance equal to pitch of the thread. Whenever we rotate a nut on the screw, complete one rotation, it will move by one pitch distance. This is the principle of micrometer. So these are the parts of micrometer. So this is the anvil and this is the anvil face. This is the spindle, and this spindle can do the rotary motion as well as the linear motion, as it is connected to the screw that is present inside this body. So an screw is having the property that it can do the rotary motion as well as linear motion. So this spindle can do the rotary motion as well as the linear motion because it is connected to the screw that is present inside the body. And all the measurement which has to be done is placed in between the face of the spindle and the face of the anvil. That's why it is called as end standard. I have already told you in the previous lecture. Next is, this is the lock nut, and the function of the lock nut is to lock the value when the workpiece is completely fitted in between the anvil face and the spindle face. This is the open condition, and when it is in downward direction, it is the closed condition. Next is sleeve. Sleeve is the part of the micrometer on which the main scale is present, and this is the main scale. There is a line in between the sleeve that is called as index line, and above the index line there is a scale, and each division of this scale is equal to 1 mm, and the division which is present below the index line is of 0.5 mm from the starting. There is a gap of 0.5 mm. So 1 mm, then 0.5 mm at the starting, and then again 1 mm, 1 mm, 1 mm. This is the thimble on which the circular scale is present, and the thimble is having the property that it can also do the rotary motion as well as the linear motion, because it is also connected to the screw that is present inside the body. This is the ratchet. Ratchet is the part of micrometer which confirms that the workpiece is now completely fixed in the between the anvil and the spindle, and there is no need to apply further pressure on the object to fit it in between. and this will be get confirmed by the ratchet, and this ratchet produce a sound that is called as ratchet sound. When we listen that sound, it will give the indication that now the workpiece is completely fixed in between the anvil and the spindle. So next is micrometer least count. Least count is, I have already told you that the minimum distance that can be measured by any measuring instrument. So the formula of the least count of micrometer is pitch of the screw divided by total number of division on the circular scale. I have taken two photographs. First one is the position of the closed micrometer in which the spindle and anvil are completely closed. It means the index line is coinciding with the main scale 0 line. Oh, sorry, circular scale 0. So after this position, I have moved this micrometer by one rotation. It means this circular scale 0 after complete one rotation comes to this position. And you can see that this division is visible to us. This division is visible to us. And I have already told you in the previous slides that the gap in the first division is of 0.5 mm. So by moving the circular scale by complete one rotation, the axial distance traveled is 0.5 mm. So pitch of the screw is 0.5 mm. Total number of divisions of circular scale is 50. So that's why the least count of micrometer is 0.01. 0.5 divided by 50, that is the 0.01. Formula for the measurement. What is the formula for the measurement for micrometer? That is main scale reading plus CSD, that is the circular scale division, into least count. Now the error in micrometer. There are error in micrometer. So first type of error is zero error. When the zero of main scale coincides with the zero of main scale, it is called as zero error. It means there is no error. There is no error. When there is no error, it means it is zero error. It's said to be zero error. Next is positive error. When the zero of circular scale is below the zero of main scale. When the zero of circular scale is below the zero of main scale, then the error is said to be positive zero error. So this error is to be removed from the final measurement, because this is the extra part which is micrometer is showing you before presence of any object in the micrometer when it is completely closed. So it is to be removed from the measurement at the final stage. So it is to be removed. It means it is to be subtracted from the final measurement. Next is negative error. Negative error means when the zero of circular scale is above the zero of main scale, then it is showing you the negative zero error. It means the micrometer is reading some small value. When nothing is present in micrometer, it will give you some negative value. So how it is removed? It is removed by adding it in the final measurement. So in this way we will remove negative zero error. So negative zero error is added in the measurement and positive zero error is subtracted from the measurement. Next is Vernier micrometer. Vernier micrometer is similar to the micrometer. Only the difference is that it is more accurate than simple micrometer. Vernier caliper least count is nearby 0.02. Micrometer least count is 0.01. But Vernier micrometer can read up to more accurate places. That is, there is a Vernier scale present with the circular scale. These are the circular scales. So one division of circular scale is further divided into 10 divisions. So what is the least count of micrometer? The way is similar to that up to this circular scale. This one division of circular, pitch of the screw divided by total number of division on the circular scale divided by the number of divisions on Vernier scale. it means it will give you 0.001 mm. It means the least count of micrometer, that is 0.01 mm, divided by the number of divisions of the Vernier scale present on the circular scale, that is 10 divisions. So 0.01 divided by 10. So we will get the value of least count of Vernier micrometer as 0.001 mm. It means this micrometer will give you more accurate reading as compared to the simple micrometer. So today's lecture we discuss up to here, and we will discuss about Vernier height gauge and slip gauges in the next lecture. Okay, thank you so much and have a nice day.